So I would like to present to you a little bit of EnginZyme's technology and our platform and how we think about things. And I'll be very happy to hear your input and thoughts about that. And I hope to give you a sort of an alternative way to do bioproduction in the way that we think will be the future of synbio for chemicals production. So let me start out by just stating what is obvious, but still, I'd like to say that we're standing in front of a monumental challenge. The chemical industry needs to grow a lot, 4 times by the year 2050, and at the same time cut emissions by half. So how are we going to achieve that? What are the methods that we are, I guess that's why we're all here, but I'm just sort of framing this because I think it's that single sentence that puts it in context. We all have to do this together. It's not going to be easy, but we have to. And it's also important, to grow the chemical industry, because what comes out of the industry are things that are really good for the planet and for our lives. Everything we touch every day somehow has been produced in this industry. And here are a few examples on how things that are made actually have a positive greenhouse gas impact. Fluorescent lamps, insulation foam, like chemical fertilizer is, we'll have more starving people unless we improve that further. So it's important to grow the industry, but then how? How are we going to do that? How are we going to produce all these chemicals? Well, I'd like to reformulate that problem into saying, how do we put nature into the factory? Nature is already producing lots of chemicals, advanced things, and that we need. And we do it differently. We use heavy metals, etc. So how are we going to take whatever nature is doing into the factory? That's what we just heard Tim talk about in some way, and I'm going to give you my view on it. So we know how to do things in a sustainable manner with fermentation, and that is improving also to become more and more efficient, as you just saw by Tim. But still, I would like to say that it still has far to go before it reaches the efficiencies of the traditional chemical plants. We need to be both. We need to be efficient and sustainable. We can't expect people to pay more for green. I believe we need to be uncompromising, not compromising on quality or cost. We need to be just adding the sustainability factor to this already efficient industry. And I believe that cell-free synbio is a good way to do that, really, removing the complexity of the living organism and just using enzymes. So I'm going to try to explain that to you. So what we do at EnginZyme, we, instead of using the entire organism, which is a fantastic thing, but it wants to do its own thing. It wants to live, it wants to proliferate, it wants to do cell wall synthesis, etc. We wanted to produce a single product, and that's tricky. So we just extract the enzymes from that cell, and we can overproduce these enzymes in alternative hosts. So those enzymes can be produced in a very cheap way in different vehicles. And then we assemble them and put them on one immobilization material in a fixed bed reactor. So for you who don't understand chemistry really in depth, that's basically a column, a pipe where you can add your starting materials on one side, and out the other side comes your products. That's the most efficient way to do chemistry, and that's the way a chemist would want to use a catalyst. So essentially, we're turning the enzymes into a powder catalyst suitable for packing in a column, and then that will become a part of a continuous process. So continuous processing compared to batch tank processing is equally, the difference in output is you can compare it with the Henry Ford conveyor belts. Really, it's another level of production. The space-time yield is much higher. So we want to bring enzymes out of the cell, put them in a fixed bed reactor, and bring the bioproduction to the efficiency of the chemical industry of today, and utilize the machinery already in place, what we already know about processing. So we did techno-economic comparison between a running fermentation process that is already commercial. And this is FEL1 standard. So, okay, it's still on paper, it's not lab work, but still it's a very detailed calculation with every unit operation accounted for in every way. And we see that we have a great advantage over this fermentation process, same starting material, same product. And this is simply from higher concentration of product in your output, higher space-time yield, and easier, cheaper downstream operation. So you just have essentially a more efficient process than fermentation when you just use the enzymes in the right way. So this is a Venn diagram looking at what we can do and what we need to do. Enzyme catalysis, I believe, we will encompass with our cell-free methods, because that is essentially what we're doing. And then going beyond that, I think cell-free can replace a big part of what you consider normal catalysis, classic catalysis today. Not all of it. Some of it is already efficient and sustainable. Some of it is not. So looking at replace that. I think there will still be a very big place for fermentation, but I think we will replace the more specialized products for it, parts of that. And then I find the most interesting thing is that all the new products that we can produce, all the things that are made in nature that is just too expensive for us to make today, that we can now address and make with the enzymes that we find. So thank you very much. And I left some, hopefully, time for discussion. I have extra slides for specific questions if you want. So I just try to keep it short to maintain the time. Thank you so much for your attention.